非常的荣幸，请到黄轩老师来跟我们演讲。好，那我想这个黄老师应该也真的，其实这些讲者都大家都不太想到我多做介绍，对，都是这个赫赫有名的这个国际级的这个学者。那黄老师常年其实他是在大家应该都知道他是在新加坡任教，那他后来这几年就是决定要回台湾啊。我们很荣幸可以请他这个回到台大来，所以他现在也是我们的 faculty。那我们大家都知道，黄老师他最主要的研究还是在于这个 asset pricing investment 这些这个 empirical study 我想在座的老师同学，我也知道，我的印象比较深刻就是这个 50 week high 的这个 paper 在 JF。一定所有的国专同学应该都念过不过他今天要讲的东西跟这个比较没有关联，但是也是非常受用的这个主题，所以今天的这个报名人数其实是蛮踊跃的所以我想这几年来这个内政性相关议题是在做研究上面大家都方法也是很重要，怎么样去用对方法用在对的地方也是非常重要的一件事情，所以今天黄老师跟我们分享的就是怎么样去apply 这个 differences 这个 approach。那所以我想这个我就话不多说，我们就掌声欢迎黄老师。对，要先搬一个牌子，所以还是先搬一下牌，这样比较后面进行比较流畅一点。这个例行的工作，谢谢，感谢黄老师。谢谢。
There's someone here in Chinese, okay? Mandarin is okay, right? Oh, okay. 我可能中英文并用，有一些别的名词啊，什么东西，可能是用英文讲还是比较顺畅一点但是就说这个，谢谢大家来到来听这个演讲and also I would say it's good to be home after 40 years overseas and thanks for National Taiwan University giving me an opportunity and to be able to continue to work for a few more years and so it's very good to be home and like to see all of you. First, I want to say, okay, I'm not an expert in differences, okay, and then you might ask why you are talking about choosing this topic for the talk. And the reason is simply I'm lazy because when Geng Yu and Wang Yanzi Laoshi asked me to give a talk and then choose a topic, and I say, okay, then I'll just use something I have taught over the years in the PhD course, and to kind of reorganize it a little bit and to so it's easy for me and much less work for me to prepare for this talk. But more seriously, I think the differences is very important tool today, and because nowadays you want to publish and indigeneity issue and whether there's a causality effect that you want to you hypothesize, then you would probably you will ask to see you need to do something like this, and with some exogenous shock, and to show indeed there's a effect that you hypothesize is there. So, and also the person who popularized the differences, the idea is Andrew Carr, right? And he just got Nobel Prize a few years ago, and so a major part of his contribution is because he kind of make a differences in his in his analysis, kind of pioneer and or make it, as I said, popularize this concept. So that's why I choose this topic, and hopefully, since over a year, when I taught the PhD course, I kind of read, then I kind of synthesize some of the material, and I get some insight, and I hope I can share that with you today. Okay? So that's the kind of introduction and to our talk today. So let's start it. So this is the agenda we're going to do, right? We're going to understand how the non-experimental work of the differences, how we're going to understand how it works, and how to test assumptions, okay? And whether there's some problem or pitfall, and we need to watch out. And lastly, right? I mean, sometimes the difference is not good enough, right? Because there's some you might encounter some situation that the treatment decision actually is endogenous, right? So you might want to do the something called difference and differences. So it's a triple D basically, and hopefully, right, depends on your design, and sometimes DDT will give you the answer you're looking for. Okay, so in science, you want to see whether there's an effect or not. It's easy to do because they just conduct experiments, right? You want to test a drug, whether a drug has certain effect, right? And you just have a treatment group and control group. And the good thing about in science, you can do experiment because this is the way you choose the treatment and control are random. It can be randomized, right? But this is not normally the case in social science, right? And so as long as it's random, your control is random, then you can use that as a counterfactual for the treatment, right? And so essentially, we have some notation here. Okay, I got. Let's go back from here. So we have some notation here. T is equal to 1 is the treatment group, right? And T equals 0 is the control group. Okay? And Y is basically the outcome you measure, and it's a parenthesis here 0, meaning when there's when it's not under treatment, right? So Y, this is 0 meaning here, meaning whether it's a treatment group, but this is the treatment group when it's not under treatment, right? And this is the outcome. And T equals 0, this means this is control group, and this is the outcome for a control group when it's under treatment, right? It's a treatment. It's under treatment. So as long as it's random, right? We can using this one. This is basically the outcome of the control group as a counterfactual for the treatment, right? So, but as I said, this can only be done when the control and treatment sample are chosen, are classified randomly, okay? Okay. So what if we don't have experiment? Well, then we would like to find a group that's exactly like a treatment group, right? Instead of randomly chosen, say this is a treatment group and this is a control group, then in a non-experiment situation, then we would like to find a group that's exactly like a treatment group, but did not get a treatment. So that when it did not get treatment, that means it's counterfactual because it's counterfactual, meaning it's a treatment group, but we like to see the outcome when it's not treated, right? So, and since we don't see that, right, treatment meaning outcome will be to be after treatment, right? But you would like to see what happens if this subject is not treated, right? And and that's something called counterfactual. And as just point out here, we would have to find a group that's exactly like a treatment group, but did not get treatment. But that's hard to do because there are a lot of things can happen because there's a lot of unobservable. Then if there's a lot of unobservable, then it's very hard to get this. But you want them to be equal, right? With the treatment and control, you want to be equal in all aspects, right? And if there's a lot of unobservable, then there's no way you can do that, right? And or data is limited, or sometimes there's even worse problem is sometimes there's a selection bias, right? Some observation end up in the treatment group because there's certain feature there and got selected into the treatment group. Okay. So this is the example of the famous example, I think classic example by Carr, right? This is the first person here, Carr and Kroger. Right? Carr here is the one that Nobel Prize based on the DID work. Okay? And this is, I think he's one of the most famous papers. I think it also contribute to his getting Nobel Prize. So his study, right? He and his and Kruger, I say we should be Kroger, okay? Whatever. They want to study when a state pass a higher minimum wage law, would that cause would that decrease the employment, meaning cause the unemployment to rise? Okay? And so in their seminar paper, they consider the impact on New Jersey's 1992 minimum wage increase from $4.25 to $5.05 per hour. Okay. And so they compare employment in the 410 fast food restaurants in New Jersey, in the eastern and the Pennsylvania area, because if you understand or you have looking at the map of the United States, right? New Jersey and Pennsylvania are next to each other, right? And the eastern part of Pennsylvania, it's just next to the New Jersey. Okay? And so they want to say, in some sense, they want to say these two groups are kind of comparable. Two states are comparable, and since the New Jersey passed the law, okay, and Pennsylvania did not at the same time, so that means New Jersey become a treatment group, okay, and Pennsylvania is a control group. Okay. So they got the data they conduct a survey on the wages and employment from two waves. One is before the enactment of the law in New Jersey, that's March 1992. That's 1 month before the minimum wage increase. And the wave two is December 1992, 8 months after the increases. And this is what we're going to see we're going to see more in a future slide. Okay. So basically, they are going to this is the first row is employment rate before the law, before the New Jersey law, right? And the second row is the after, right? The employment number. And of course, PA, the I, this is the Pennsylvania and New Jersey, right? And these are the differences, okay, for the before, after the law. You can see the difference. If you just compare these differences, you can see it's 2.89, okay? Meaning there's a, it looks like New Jersey has a decrease or employment, right? If you just look at the first row, right? But if you look at the second row, I'm sorry, this is before New Jersey has a low employment rate, okay? And the up, when it's afterward, right? New Jersey is still lower, but it's insignificant now. Between the employment rate between significant difference between New Jersey and Pennsylvania, right? And the key here is even this is no difference, but compared with this before difference, right? It's actually positive, although it's not really significant different, but it looks like not when you increase when the New Jersey passed the law, okay. And you want to measure the impact according to difference methodology, which we're going to get into more in detail. You can actually show, right? There's some increase in the employment after New Jersey passed the law. Okay, so this is kind of a teaser. I mean, we want to see that kind of give you a preview of what we would like to see or what DID can give us. Okay, so if you don't get it at this point, that's fine, right? Because we're going to have more discussion about this. So the basic idea of the difference is in experiment, we're going to use the difference of treatment and control group to estimate the causal effect. Okay. And in a non-experiment case, we don't need a counterfactual because we don't observe the outcome of the treatment group when they don't treat it, right? So that means it's the same notation again. T equal to 1 meaning it's a treated group, but in the 0 here meaning the outcome when it's treated group or not treated. What happens if you don't want to treat it? What will be the outcome of that group? As I said, that's called counterfactual. So often we would like to find a treatment group and control group who can be assumed to be similar in every way except the difference between treatment and except one group received treatment and that's a treatment group and the other group did not receive treatment and that's a control group. We want to say we want to find two groups that are identical or assumed to be similar in every way, right? And except the treatment. Yeah. But as I said, this is very difficult to do. Yeah. So this is what we striving for if we can get it, right? But this is difficult to do. So we just need a weaker assumption, right? Instead of assume they are identical in every aspect except the treatment, we just say, okay, there could be different between these two groups, but their difference are constant over time. Yeah. So that's a weaker assumption. And with this, so this is the idea behind the DID. And this assumption that the difference between treatment and control are constant over time is the same as something called, some people call the common trend assumption or parallel trend assumption. Okay, so that's exactly the same as the difference between control and the treatment are constant over time. Okay? So that's exactly that's the graphic representation here, right? So this is treatment group and this is control group, and they are different. they are different because, as I said, it's hard for us to get to come up with a design that and make it control and treatment to be identical, except in every aspect except receiving a treatment, right? So we allow it to be different, and that's what you see here. But the assumption is, the weak assumption we're going to impose is this difference are constant over time, right? So that means this group, even after treatment, even when the treatment group got treatment, right? And this is what happens if they don't receive treatment, right? So this is called counterfactual. Remember that notation earlier? Notation here. Right. This is counterfactual. Right. This is what happened. It's a treatment group. What happened if they don't get treated? Right. And we will never observe that's a counterfactual. And the assumption we're going to impose for the DID to work is we're going to say this difference is constant over time, meaning the difference here is the same as the difference here. Right? So essentially, we are assuming there's a common trend, right, or trend parallel. Yeah. So I think that's the basic and most important idea for the DID to work. Yeah. And so in this graph, you can look at the A, B, C. So if some people, right, just when they do it, when they want to conduct, whether they want to measure whether there's an effect on treatment, some people just do after the treatment, I just take a difference between A and B, and that's called standard differences, right? Standard difference, right? And the user say, oh, that's an effect because there's a difference. Okay, but as I said, some of the difference here is already contained. There's something we call the normal differences, right? Normal differences. If you treat these two groups, we assume they were different, right? And they continue to be different if this control group is not receive treatment, right? So these differences is the same as this one here, right? Because you assume their differences are constant over time, right? And this difference is called counterfactual normal differences. Okay. And the idea of DID is basically we're going to measure the impact, whether there's a treatment effect. I mean, whether the impact of treatment. We are going to measure the difference between, we're going to use an A minus B and take away the difference between C and B. Okay, and essentially we're going to take, this will be the effect we're going to measure. This will be the real effect, the correct measurement of the effect. Okay, so that's the kind of most intuitive and the simple idea of the DID. So again, we can say again the assumption of the difference estimate is we're going to assume the trend in an outcome variable the same for treatment and the control group, or essentially it's the same as their difference are stay constant over time. Right? The difference will not grow or diminish. Right? They are constant over time. Yeah. And the most important, so this is the same as common trend. Some people say the parallel trend, untrend assumption. Okay. And the second point is actually quite important, and for some who study the DID did not recognize it at the beginning, is that this parallel trend assumption is equivalent to assuming a panel regression is governed by a fixed time and fixed group effect. Okay. So if you run a regression with a fixed time and the fixed group effect, it's essentially assuming there's a parallel trend. Okay, so if a model, if a regression, and if a DID and cannot be completely described by a fixed effect, fixed time effect, or fixed group effect, then if you run a DID using with just a fixed time effect and a fixed group effect, the DID measurement will be invalid, right? In a sense that you might have to include other effects like firm ear fixed effect, something like that, or the otherwise you're going to have a mismeasurement. Okay, because this is essentially parallel trend or common trend assumption is essentially assuming this parallel regression can be just described by a simple fixed effect regression and a process a fixed group regression. Yeah, and they are identical in a sense. Okay. So, but this assumption, right? And this, of course, I mean, you have to question yourself. Sometimes you need to or referee would ask you to take test the assumption, right? If there's only two periods, then you cannot do anything, right? But if there are more than two periods, and sometimes there is something you can do. We're going to see more. Okay? You can actually test some of it. Okay? Test some of it. So let's get some notation, right? So this is the y is as an I is an outcome, and the mu is just expected value of the outcome, and I is equal to 0 is the first the yit, right, or mu it. There are two subscript. The first subscript I indicate whether it's control or treatment. So 1 is treatment and 0 is control. The second subscript describes the time, whether it's before the treatment or after treatment, right? And t equal to 1 is post-treatment, and t equal to 0 is a pre-treatment. Yeah. And remember the standard difference here. Okay, right? It's the standard difference is A minus B. It's a difference of treatment and control after in the post period, right? So that's you can see that's how we define here is a standard difference. Okay. So standard difference, right? One is the right. Remember the first subscript. One is whether it's treatment, 0 is control, right? And the second subscript, right? 1 is post treatment, right? So the standard difference is basically mu 1 minus mu 0 1. Right? And if we're using this one to measure the effect of treatment, just using this one, then you essentially assume there's no normal differences. There's no normal differences, right? And in this estimate, basically we are assuming we can using, right? This is just like a science experiment, right? And if the control and the treatment are chosen randomly, right, are defined randomly, then we can just using these differences. This will give us the answer of whether there's effect of treatment, right? And so essentially in this estimate we're using, right, t equals 0. This is the control group, right? This control group and what happens if there's no control, right? And as a counterfactual for this. I mean, zero meaning when there's no treatment, right? So essentially, in this estimate, we're using this one as a counterfactual for this one. Using the control group when there's no treatment, because control group never receive treatment, right? Because using control group value as a counterfactual for the treatment group. That's essentially what happened. Right. And say another way is we're gonna if we do this, that's basically we're assuming there's no difference between the treatment and control. Right? And if we look at the graph, right? This is the real effect on the measure, right? And if we're using this effect to measure and call this as a real, so call this as a real effect, that means we have to assume there's no difference between these two. That's essentially the statement we saw earlier. So the TID is basically this minus this. So this is the standard difference, the area. This is the normal difference, right? Normal difference meaning this is the before the zero is before the experiment, and this is the treatment and this is the control, right? And before the treatment, and that's the normal difference, right? So we're going to using the TID basically the actual difference minus the normal difference, and that's the basic TID. Two differences. One is the actual standard difference, and one is the normal difference. And you can just this is just the kind of rewrite this number, just move this number here, move this number here, then. This where the DID estimate is before and after difference for treatment group, right? This is one is treatment and one is after, one is zero is before, right? So this is the before and after difference for treatment group, and this is the before after difference for the control group. So that's what the DID means and how to estimate that. And if you look at this is same as we calculate the difference, right? Because before and after difference, we calculate we are running a difference regression, right? This is the difference in the outcome of I before and after, right? And basically change of the I before and after, right? And regress that whether there's a treatment, this is the treatment or it's a control. If the treatment, it will be zero. I mean, if the control, this will be zero because there's no change. X is the measure whether it's under treatment or not. Equal to 1, it's a treatment, and 0 it's not, right? So for control group, it's all 0 before and after, right? So the change of the X is 0 for control, but for the treatment, change is 1. And this beta will basically just give you this idea. Okay, so we can do this, but run the difference, the first difference, the regression, right? But this is sometimes you cannot do this because you require in this kind of regression, kind of cell difference regressions, you need to have the data or the same form before and after, right? The treatment, but sometimes we don't have that, right? And that's why the people run a regression similar like this. Okay? So instead of running the difference, you are running at the level YIT, right? On the XI and E capital T, right? This is capital time, the before and after, right? And this capture whether it's a treatment or it's control. I think there's some mistake here because this should be beta 1 and this should be beta 2. Let's skip this. This is not quite critical. Is the interesting is how to get. I mean, I want to make a connection between this regression and the regular panel regression with a fixed effect. Okay, when you do the DID, right? So this is according to what we say we can detect the DID based on this. This is beta 3, right? So X, I, and T, and the interaction between X, I, and T, and beta 3 will be the DID, right? The differences. Okay, and as I said, X, I is indicator, whether it is treatment of equal to 1 is treatment, and I equal xi equals 0 is a control. And T, capital T, when it's 0, it's before, and when it equal to 1. So this is basically all dummy variable. I think this all dummy. T, capital T, it's equal to 1 or 0. 1 is after treatment, or I would call it in the post period, right? I mean, for control, it's in post period. It's not really after treatment, it's just a post period, right? So there are 2 periods before and after. Right? So if I kind of extend this equation here, what? Okay. So I'm going to rewrite this equation, but I'm going to change it to be easier to interpret it. We just change the I to S to like a state, right, instead of the individual fund. So I mean, just to connect with the Pennsylvania, New Jersey example we saw earlier. So this is equation we saw earlier, and I just make it easier to make I change to S, so nothing happen, right? Except change I to S in the subscript. Then the beta 0 and beta 1, and this is the one indicator, XS. And when S equal New Jersey, right? Remember that when it's in New Jersey, it's experimental, right? And so that 1, when in New Jersey, this is equal to 1, and otherwise, when S equal to the other state, the only 2 states, one New Jersey or one state Pennsylvania, right? So when this is Pennsylvania is 0, so I can just rewrite this as this, right? In this equation here. And this applies to the T, time dummy as well, right? Remember the pre-period is a March, right? Is it March? Right, and the post period is November, right? And so T capital T, when it is November, that's the post period, and you assume time equal to 1. So this is just a rewritten, and with the interpretation of variable in our early example. Right? And what's this interaction? TT times XX is an interaction of 2 dummy, right? And when this is equal to 1, so since we already defined, this is November, so it's just November here. This is XS is equivalent to this unit indicator. So this is when it's the S equal to New Jersey. Right? So if you look at this, this is equivalent to a fixed effect regression. exactly the same as a fixed effect regression, right? Because this is a state fixed effect, right? Gamma S, right? That's basically the difference between. So this you can think of this as the fixed effect of a state or just and the time in a pre-treatment period for Pennsylvania. Gamma S is a state fixed effect, right? The major difference between New Jersey and Pennsylvania, right? And gamma and lambda T is a time fixed effect. The time fixed effect is the difference between post and the pre, right, period, right? So beta 3 would define this dummy variable DST is basically when T equal to 1 in the pole period in November, and S is New Jersey, then DST equal to 1, otherwise equal to 0. Right? So some people just interpret this as in this only 2 periods, but when you see in the multi-period, you can see this will be defined as this equal to 1 when the state S is exposed to the treatment by the time of T, right? And that value equal to 1. Right? So in the 2 period, right, you can see when it's November, by the time of November, and this equal to 1 when it's a New Jersey, S New Jersey. Right? Only when it's a New Jersey and when it's November, it's equal to 1, otherwise also 0. Right? So that's the kind of state, a simple fixed effect version with state fixed effect, time fixed effects. And the beta 3 here will capture the difference estimate. Huh? So I'm trying to make a connection between the planar regression of fixed effect and the normal kind of the dummy, the control and the treatment and the pre and post kind of type of regression, more kind of event study type regression before and after, then with the control and treatment. I mean, right. So this is the standard level, and sometimes you're going to run a regression with the individual form level, and J would be, we can represent as a form in state S or at time T, right? That's the outcome, right? And so nothing different here except, right? You just have this one now is instead of all the state aggregate together, average, but if you would like to keep the individual form outcome, right? Like this, right? With this, you can control for other variables. This is the characteristic for the form S, form J in state S at time T. You can control variable when you run the equation. Okay, you can control for the difference in their characteristics. Okay? So again, let's come back to see how we say now we're going to have a fixed effect regression, and how does it looks like in our graph, right? Or how that relate to the common trend assumption. And that's this graph here, right? So remember, this is treatment, right? Exhibition outcome. This is the control, right? And this is the counterfactual, right? Remember earlier, it's a counterfactual, right? And how is that related to the fixed state effect? Well, difference between two states, right? And remember what's the fixed state effect? This is the state fixed effect, meaning the difference does not change over time, constant, right? And that's exactly this thing. Yeah, you got a parallel trend, and that's basically the kind of mandated by the state fixed effect, right? And there's a time trend, right? And the time trend is, you can see there are these two are parallel. That means the time trend of this one and this one are the same, right? And that's basically the fixed time fixed effect, right? Time fixed effect is constant for all the different states. The change of the trend, I mean the change, the value over time are the same for different states, right? And that means they have the same slope, right? And the difference of this, you can think of this as slope of this capture the time fixed effect, right? So, and we said this is our DID, estimate. So, this is how you connect, like how we connect a fixed effect equation with the graph. And why the fixed state effect and a state fixed effect and time fixed effect is the same as a common trend assumption. It's equivalent. They're identical. They're identical. So this is the kind of recap assumption for different indifference. Right? It's basically, the most important thing is a linear model with a group of time fixed effect, and they enter additively, right? It's a linear and additive, right? And no spillover effect. The treatment group would receive treatment, and the control group did not, right? There's no kind of no spillover. And the most important thing is common trend. They are in other words, remember, common trend is a weaker assumption, right? Because the strongest assumption is what? There's no normal difference. The control and the treatment are identical, right? Except the treatment. But we don't require that, right? We allow them to have a difference, but we just require their difference to be constant over time. Right? So obviously, it's a much weaker assumption, right? And what happens if the difference are not constant over time? Then the DID fails, right? Whatever the DID measurement, right? So if this happens, that means the common trend does not satisfy, right? Because the difference value over time, that is equivalent to what? To the gap, either widen or kind of narrowing, right? And that means DID is going to fail, right? Whatever you run, if you just run a simple regression, right? You just run this regression, the D here will not capture the value DID estimate, because it said this regression is not correct, right? Because it's still missing something, right? Other than just time fixed effect and the state fixed effect. Okay, is that clear? I think that's the important thing to recognize, to make a connection between the fixed effect regression you see most of the time and why it failed. Why it failed, meaning if let's say my point again, right? Common trend assumption is not satisfied. That means the difference change over time, right? Then you just simply run this regression. The D here is invalid. It's not the correct estimate of the DID. So that's the message I try to share with you. Okay? Now this is I think this is a good example here about when you do a test, design test, and some people want you to see whether the common trend assumption is satisfied. And this paper actually done it well, and it using graph to show that, and actually the common trend is something quite satisfied rather nicely. Okay, so this is the paper at AER, right? Called Vertical Relationship and Competition in the Retail Gasoline Market, okay? By Justin Hastings. Okay? They are interested in the effect of the vertical integration on retail petroleum price, gas price, basically. Okay? So the clever thing they did is they take advantage of the event of there's a chain of kind of 50 about a name. Meaning this is kind of discount. And they kind of discounted the gas station, right? 50 gas station chain. They're going to take over by a alcohol, a gigantic conglomerate, right? The gas company. Okay, and they want to investigate. Once this happens, would that affect the competition? And with the gas price, which is normally under competition, going to go up or go down, or go to essentially any impact when if a merger, a vertical integration, would that affect gas price? Okay, so that basically using this event, right? I mean, I think that's clever, right? As I said, they come out with design to answer this question, right? And they notice the ARCO is taking over 50, so they define the treatment group as the petroleum station within 1 mile of 50, meaning they are under competition before, right? So will be affected by this integration, the vertical integration, right? And they also define a control group is outside of the 1 minute, 1 mile. I'm sorry, 1 mile from the 50. So basically, the station, not 50, but is a station close to 50 within 1 mile circle. Those are going to be affected by this merger event. And so that's the treatment group, right? The one outside of the 1 mile of the 50 is the control group, because they are not going to be exposed to this vertical, the effect of the impact of the vertical integration, right? And you can see the graph. That's probably, if you can do a study like this, and usually if you are able to provide a graph like this, then I think the referee will be more convinced, right? You actually, right? And so this is the one within this treatment group, right? The solid line, the gas price, right? So this is this time is the merger. This is the vertical integration happen, right? This is the treatment group. You can see before this happened, the firm under the solid line, the treatment group actually had a lower price because they have a competition there, right? And this group has no competition, right? So that's why they give them high price. So these two groups, the treatment and control, they are different, right? They are different. And you might question we can do it with the DID because you might question whether this is a good control group of the study. But as I said, when you do DID, only requirement is their difference are constant over time, right? And essentially that translates to whether the trend, right, before the treatment, you when can test that, you can test that, you will see whether it's a parallel to this one. And indeed, that's the case. So common trend assumptions are kind of nicely satisfied in this example. Then you can see after the treatment, right? This is the treatment happening here. The merging actually happens, right? So this group no longer under competition, right? They used to be under competition. Before they no longer under competition, and you can see the share price jump up more than the control group, right? More than control group, and that's the way it show, right? Vertical integration impact the competition and the gas price. I wish I can do a study like this too. I mean, in a finance context, right? But sometimes we need to notice. There's another example, and these are the kind of famous because they even got a name for it called Eschenfelder dip, right? So this is kind of education or job retraining program, okay, for participants. And this is the idea of there's selection bias, meaning for the people getting to the program, actually something happened to these people, right? But the idea here is they want to test, right? So this example is trying to test if the government-sponsored training, right, program, the JEP program, that affect the earning of this worker. Okay, so of course they will compare two groups. One is enter the training program, and the one doesn't, right? And one is treatment, one is control. But the problem is, you may suspect those person who end up into the treatment is kind of self-selected in a sense, but they might have something bad happen to them, right? For example, right? So this is the person, those person enter the training program. This is the training program start, right? This is those person. This is a control group, right? Control group for those worker never or did not enter the program. But for those enter the program here, right, you can see clearly, right, along this time here, something happened, right? They might be identical before, these two groups, right? So we have good control, but it's going to happen here. This one kick up and come down, right? And especially this part here, right? This part here, this one, it can be interpreted as, well, if a worker coming to training, their earning will be less, right? Because they have no time to work, right? So, and this one here might be actually something bad happened, and probably temporary, right? And that might also trigger they enter the program, right? They might say, oh, okay, since I kind of suffer the wage loss, then I want to enter the program. So if we do a DID based on this graph, we're going to measure the difference between this and some normal difference between before. Then that's going to be overestimated the impact of the training program, right? Because say you want to DID basically are going to measure the difference between this and this for the control, and the difference between this and this of the actually here actually you want to measure the difference between this and this and this and this, right? that's going to exaggerate the impact of the training, right? So because we know something happened trigger the entering program, so it's safer to actually do it, compare this difference with the difference and this difference. Right. It's still not ideal, but that probably is better than just compare that it's still more accurate. Right. Compare the difference, the tip of this two, and the tip of this two is still much better than compare the tip of this one and the tip of this. In terms of measuring the impact. Okay, so this is something to watch out. So not just, and that's why important, right? It's very important. If we can have enough data, can make sure we can do a study of this, you want to plot the earlier period. Right. Like that you not only to see whether the common trend assumption are satisfied, and if not satisfied, you might want to investigate why, and there's a remedy to take care of that, right? Okay. So another way to see, I think, a more rigorous way to see a common trend assumption to see person is satisfied, actually is something called strict examination. Okay. And T is equal to group, T is the time, and Y is before is the outcome, right? And this is J is either 1 or 0. Remember, J is when it's under treatment, 0 it's not, right? And you have the AG, BT, that's a fixed, that's a, you can go fixed effect, this is a time fixed effect, you want to run a fixed effect regression, right? And for the strict exogenarity, it means the expectation of this one is same as this one. Right? And what's the difference between this and this? I condition on D here, the treatment. Whether DGT or when you got treatment, DGT, remember DGT equal to 1, indicate the group G is under treatment by the time of T. Right? So this is basically when this is identical or same, that means DGT is kind of independent. The decision to get a treatment or get a treatment is independent of before characteristics or the outcome or the after. Right? So it's a very, very strict assumption. I mean the requirement. Okay. But that's a simple case of that is actually it's a common trend. Common trend is essentially saying the same thing, but this is a kind of more strict way to say, right? We said verbally said after conditioning on the group and the period fixed effect, that's this and this. Treatment exposure, right? That's this, right? Treatment exposure, right? That occur at the t+1 are not anticipated by the outcome. And this is either before actually or after. Okay. So what happens when it's anticipated, or the example we see here, those things are actually, if this happen, that means this decision are anticipated, right? And that will be the case like this. This one. Okay, I don't have it. What happened if we anticipated the common trend? I don't have here. Somehow the slide I put in is not in here. Okay, right, if this is true, that means it's not anticipated. Common trend assumption is satisfied. Okay, but what happened? What if anticipate? What it looks like? It will be looks like this, something like this. You will not be parallel before. Right? There's already differences predict there's the D coming up or the treatment or this group. In other words, the difference before the treatment or basically you can take a normal difference, right? Actually can predict which one going to be enter the treatment or not, right? So that's inconsistent with the common trend assumption, right? But more mathematically, I mean, going to have tighter definition and the requirement that's the strict exogeneity. It's the decision itself to enter treatment itself, which state when to pass the law, for example, is exogenous to the outcome variable. Yeah, to the outcome variable. Okay. Is that clear? So as I said, and this is the exposure would mean this is not satisfied, it's biological. We don't see this, this is the example of that. We are going to see this, also the example of that, basically. Right? The difference, as I said, the normal difference can predict the whether this group is going to enter treatment and this group is going to enter and become control. Right? And one example is, for example, this is violated. Many law or policy change decision may be endogenous. For example, I mean, we're going to see this example. For example, this is a famous paper, right? Bertrand and I think 203 with his co-author. I think the kind of summary drawn out here. Okay. Or these two examples we're going to see, or the maturity benefit expansion of Hoover. Okay. The low passing, these low passing are likely to pass in a state with a better economic prospect. Okay. In this case, common trend assumption would also be violated. Because it's going to violate the strict exogenous assumption as well. Right? And that's something like this, right? We will never see this one here, but there could be an economic concern. There's a concern, right? That is what happened after. If there's no treatment for control, right? This is actually going to go faster than this one. Right? So it's like, for a common trend assumption, we want this one to be the same as this one. But if this happens, what does this mean? This means the future outcome or the state actually are different, right? And that might be the reason they pass the law, right? So basically, the law is endogenous decision, not the exogenous decision. Right? Is that clear? I think this is the kind of important thing to understand, right? Or you can take even in some cases even reverse causality, right? The law happened. It's the law does not change the future outcome. It's because there's a future outcome, right? You're gonna kind of because future outcome happy that cause the state to pass the law. Right? And that causality, as I said, causal direction is completely meaningless. Right? And if that's the case, then the regular, because if that's the case, then we don't get a common trend assumption satisfied. But even you cannot test this at all, right? Because we never see this. Before we can test, right? Because of observation, right? The control, when there's no treatment, before the treatment, then we observation to test that. At least to test this part. But we don't have data to test this part. Right? But if there's enough economic argument to say, hey, this might not be correct, right? This might be actually these two trends might diverge. Then we might have to suspect that your DID, right, might not be right major, will be biased, right? And in that case, right? In that case, right. In that case, we might want to do a DDT, which is we're going to talk about it. It's a major part of the talk after we come back. Right? After take a break, then we. But before take a break, let me finish a few more things. Right. So this is the graph that possibly tell you possibly that treatment decision are endogenous, not exogenous at all. Right, and common trend is something would be violated. This is a way to test, right, the common trend assumption, right, and there's a famous type of the causality test is designed by Frazier, right. So if you study time series, right, the Granger type of causality test it's well known, right, and we're going to go on, right, to see whether the common trend assumptions are satisfied, right? We can run this Granger type causality test. And this is a general relation. Right? This is a fixed effect relation. Do AG time fixed effect, right? And DGT here, T equal K, meaning the state of S, the state of group G, pass the law or whatever or treatment become effective at time K. Okay? And the other variable here, meaning this is DGT at time equal to 1, if T equal to, if the T is S period before K. Right? K is K is the day, a state X pass effect, a pass law. Right? And this dummy is defined whether it is 1 period before, 2 period before, or 3 period before, or S period before, right? And it's a dummy variable for that, right? And remember, if the common trend assumption requirement is what? Common trend assumption meaning the decision or the exposure is not anticipated, right? And if that's the case, that means all those variable coefficient should be insignificant, right? Is that clear? Right? But right? Here is the day the treatment start for group G, right? If the common trend assumption happen, right? All this effect, right? Meaning if this happen, right? If this is equal to say when S equal to 1 period before the state pass the law. If this is significant positive or negative, that means this one could affect the outcome variable of the future, right? Of the future, and that can that means you can predict the in a sense that the exposure can be anticipated. You don't have to run. Yeah, if there is a common trend assumption is satisfied, all the gamma S the range depends on data. But in fact, we see a lot of the paper actually we do when you do the pendulum regression, the decision variable sometimes people show -1, -2, -3. That's exactly this. That's exactly this, right? And they want to argue all those before the exposure, those effects should have zero impact on the outcome variable. Right? If a common trend assumption is correct. Right? For DID to be correct, basically. Right? And what happens is this. This is just this is the same or identical to here, but what happens if we also add this one? This is the basic one to measure whether the impact post-treatment are different. Right? Are they growing over time or are they diminishing? Right? And you can tell, and this will tell you. You can just plot the lambda s over time and wait to see whether it's going up or going down. This is the time varying treatment effect. Time varying. Right. The treatment impact must start, then it might take a while to go up. On the other hand, it might kind of go up immediately, but kind of decline over time. Right? And that you can answer that question by adding, using this specification. Okay, so this is the treatment anticipated, right? We see that. Well, this is the one, right? The treatment anticipated because you can see the difference of this one here, and that's why if you run the equation, the earlier D, right, would have a positive or would a significant coefficient, right? If we have this, right? If we have this, then we run this equation. We run this equation. The gamma S will be significant. Right, it will be significant from zero. Right, and that's clearly right, and that clearly violated the treatment anticipated. And here, there's sometimes you want to other way to test the common trend assumption, right? You can add a time trend or a group specific trend. Right. Again, if there's a group have a different time trend than the other, then again the common trend assumption is not satisfied. Right. So if beta G, right, if this is significant, I mean that's a non-zero group specific trend, then that's an indicated violation of the common trend. But some people might using this one to say, okay, I run this equation as well, but also run one without a group specific trend, and to see whether these two are very different. If they're very different, they can argue, well, even this is not common trend assumption is not completely satisfied, but it's good enough for them to accept the DID estimate. Right? That's how in practice that's how people use it. Right? To apply strictly, this is a testing whether the common trend assumption is satisfied. Right? But in reality, in practice, people just run two. One is a group specific trend and one without. And to see whether the estimate of delta, when you look at estimate data, are they very different in the two regression, right? If they are very different, then this is a group specific trend actually is a strong violation of the common trend. But if they are not too much different, and you can argue, well, even a slight violation of this common trend assumption, as long as a groups under the category of the group specific trend, that seems okay. You can accept that, right? Right, the different type, the different you can see. Okay.
So about the AG here is firm characteristics, a group characteristic.
Which one?
So the AG.
AG is the group. This is this is the group fixed effect.
Group fixed effect.
Yeah, can assume. I can subsume all the other characteristics you can think of. Right? Or related to the or state G. It's only in the same state. They have the same this same fixed effect.
But I'm just thinking the time trend mean the usual time trend, or we should interact with the group fixed effect.
No, this is you can change this the year even calendar year. This is can be this is time, right? Time t is the same here. This one, but it can indicate it's which year. Okay, I think that's when it's time to take a break. Oh, okay. We'll come. We're gonna say. We'll come back. We'll say a few words about a caution about. This is the most recent development, right? Because of the 22 GFE. It's a caution about using the DID when the event are staggered, right? And when you run a panel regression, that what we have. Okay, so maybe the break for 20 minutes or something. Okay, let's get started. Uh, Before the break, we talk about if we just run a DD blindly as a fixed effect regression like this, we might run into a problem, especially when for example, the D. This is the law passing example, right? When certain state pass the law, certain law, then the state or the corporation in that state will be under treatment, right? And when we unlike the earlier regression, the earlier one, before we jump into the right, here we make a switch, right, from this type of regression into a fixed effect regression, right? And the difference in this regression and this regression here is we have a clearly by specified treatment group and control group, right? If we want a regression like this, there's no explicit treatment of the control group. And in fact, we're going to using all, especially, I mean, when there's only two states, that's not a big problem. But if there are multiple states, multiple period, okay, and for a control group, right? So in other words, different states pass the law at a different time, right? And when you run a fixed effect regression like this, we are implicit assume, okay, in a particular calendar time, calendar year, if DST of this firm is not, or at this time, is not 1, right? Then that will be including as a control firm, right? Even though some of this firm actually were in treatment group before, right? Can you see the problem here, right? When we do this is more like an event study type. We are clear, we know, right? Before and after, right? We have a control and the treatment well defined. But when you run a regression like this, similar to this, right? We are implicitly assume we're taking all the firm for t, st equal to 1 in that period, we are including them in control. Even this particular state had passed a law, say 5 years ago, but they will be treated as a control group, right? In the later event. Okay? So that is a problem. A problem. That's why, and that's the paper, right? That's what we say here. This paper, right? This paper last year, JV, right? They talk about estimating can be biased in such cases, right? And what cases we talk about? Right? When you run this equation, all the firm not in treatment at time t, meaning this value, when the value, this DST, when it's equal to 0, then all those observations will be included as a control, treated as a control. Okay? Even they were in treatment before, right? They were already in treatment earlier time, right? This state already passed the law. If you think that past law is treatment, right? For state which passed the law earlier, that's in earlier time they were treated as a treatment firm. But later on, they will be counted as a control firm when there's another state, right? Pass a law at a certain time, a later time, and that state, which has a law passed earlier, this value is equal to 0, right? Equal to 0. Okay, because this DST is defined based on state, right? And different state pass at different time. Is that clear? Right? So that might cause a problem, and for detail, we don't want to get into detail, but we're also interested to see this paper. And the possible solution is we choose the control group specifically, right? I mean, this problem, when it occurs, right? If the state passes a law at 10 years apart, normally that's not too much a difference, because we can already assume that this effect will kind of die out maybe 3-4 years after the law change, right? So it's if 10 years later, right? 10 years later, there's another state passing a law, right? Then even the state which passed the law previously, their treatment effect dissipated already at a later date. So we can count them as in control group. I mean, we're not causing too much a problem, right? But when the state pass a law stagger and they are in close range, they are clustered in certain year, then if we just run this regression blindly, right, without taking care of if we don't do any further treatment, then we might encounter, according to this paper, there's going to be another problem, right? So either we choose this one specifically, as in the paper next we're going to see, Gruber, or as I said, we can do an event type study. Like go back to this format. Okay, go back to this format. Yeah, go back to this format. Right? And define a window, say 2 years before, 2 years after, right? Can do an event study, but in a regression, right? Okay, we have pre and post, right? And then the pre-post for different studies at different time, and we can make sure, right? The some of the firm and the post window will not become will not be in the pre window, right? Of the next event. But if we can avoid that, then we're going to see in the Google paper, actually they can lump together. Lump all this, when all the law passing within 3 years, you can lump all the 3 years law, the state. The law it's one group, right? And that's a possible solution if that happens. Is that clear? Okay, then we're gonna see the example. Okay. So we're gonna see the example. Maybe we come to that. I mean, when we talk about DDT. So the first example is if this paper, right? They do the DD was used as a kind of talking point or as a kind of poster boy for the paper previously. We point out, right? This paper was criticized. It's an example. This paper, they criticize this paper. Say it's a stagger. Then the title of this paper is right. The title of the paper is how much we can trust the stagger DID result. And they also make some suggestion about how to take care of that, even possible, right? Sometimes it's not possible, right? So, but let's come to this paper. This is early, right, 2010, and I think the DID paper, and they study a law called most state remove restriction of interstate branching. Right? I mean, the banking. There's basically a banking law, right? And they have restriction about how many branch, right? You can have, right, for a certain bank. Basically, they want to reduce some competition in the earlier time. But from 1970 to 1990, there are more states remove the restriction. So you can have as many, as a bank, you can have as many branch as possible, right? So because if there's not enough branch, they are arguing some of the population will not be served, right? Some, especially poor people, they might not. If the bank is far away because the bank cannot make money, right? In certain range, right? And they will cut back the number of branches, right? And also they kind of remove the competition, right? But if this is coming back, right, they want to show, right, whether the competition can improve the bank efficiency, okay? But the question they ask is, can they affect the income distribution? Basically, they study the Gini index. You know, the Gini index is wealth inequality, right? Some people are very, very rich and some people are very poor. They only study whether this removing the banking ranking restriction would that improve the Gini index. Okay, so where there's a causal effect, okay, that's the idea. So that's a simple, right? So that's a simple DID relation, DD. This is just a difference in difference equation, right? And we run this regression. Okay, run this regression. We see this: A, the state fixed effect. B is what? The time fixed effect, right? And the D, right? Remember this D is by the time the time T is a state is exposed to the law, right? Exposed to the law, right? By the time T, right? it's equal to 1, yes. If equal to 0, no. Right? And they have 49 states or 50 states in the United States. So of course, one had to be you're gonna have a dummy for all 50 states. Right? One had to be let out, right? Otherwise, there will be a multicollinearity, right? And you have the BT, right? And you have T, the year, basically from 1976 to 2006. So they just simple run distribution. And the dependent variable is the Gini index. Gini index. Gini index measure the, if Gini index is large, that means the wealth inequality is large, right? So that's what they did, right? They just simple run distribution, and then with control in panel A, we know control in panel A, with the control other control variable in panel B. Okay. And the thing is, if you look at the order regression, right, all the independent variable, all the different format, right, and the coefficients are all negative. This DST basically is this one, right? The bank devaluation. DST equal to 1, meaning by the time t, the bank in state S has been deregulated, right? And it has an impact on decrease the Gini index. Okay, and they got a paper in JF, right? That's the yeah. I think the 2010 the DID become popular or kind of more like a kind of requirement, but I think these people are the early ones to adopt that, and they got a nice paper out of it. Right? So, okay, they also look at the different group, right? The ST is a state S and the time T. They look at different group distribution, right? The very poor and not so poor, right? And they want to see whether their effect of this regulation are different. And this is what they found. They found yes, it's different. These are the percentile income distribution. The 5 percentile, that's the poorest one. And right. And you can see that they are different of a different group. The poor one actually improve more. The poor improve more in terms of negative index. But this is similar, right? Remember early time we talked about we run this regression. We're running a granular type of regression. This one here. This paper, they do that too. This paper, they do this, and that's here in this graph. In this graph, let's see it here, right? The BST minus 10, that's 10 years before the duration, right? BST minus 9 is 9 years before, they're all the way to 15 years after. Right, so this is basically, and they run this regression and they plot the estimation. Right, beta 1, beta 2, so beta 1 will be this one, beta 2 will be this one, and you can see, right? And this is the confidence interval, right? And all these things are basically all insignificant, right? Because they all confidence interval are all on the two sides of the including 0. So basically, all these minus 1 are all insignificant, right? But the plus 1, right, is the post, right? So this is a post effect, right? The effect of regulation. You can see they are different. But remember, we do this for time varying trend, right? What does this mean? This means the negative decrease the Gini index, and this comes interval is here, it's below 0. So this you can say this is a significant difference from 0. Right? This idea, right? When you want to plot a you can in a few study, if you do this, you can do a similar part like this, right? So this clearly show this degradation is not anticipated, so it's really exogenous, right? Satisfy our earlier definition of strict exogeneity, right? Degradation is not anticipated, right? And that's why we see all this beta 1, beta 2, all the way up to beta 1, beta 2, all the way up to beta 10, right? They are all incidentally different, right? Indicate common trend assumption are satisfied, right? You can see this common trend assumption are satisfied here, and the post one is major effect, and you can see the effect actually become grew over the year. Actually, it take maybe 7-8 years to have a really big impact in terms of decreasing the Gini index. Okay. So because this is a long-lasting effect here, then that will cause a problem, right? Because I said earlier, we might try to do event study. We can limit the window, and arguing maybe after year 5, this impact disappear, right? So this effect here from the treatment group will not get into a control group later on the next event, right? You see that? What is the implication here? In this case, we cannot do an event study even to limit the window because the effect lasts for almost 15 years, right? If you can exclude them, then we don't even observation to study, right? So we kind of stop. So maybe that's the reason they pick this paper to criticize, to see if this happened, right? And all those effects here become a control group effect, right? Then you're gonna, but if this is negative, become a control, then you're gonna underestimate the impact of treatment later on, of the later group, right? Because this is a negative impact already from the previous one, they are become a control to be compared. Oh no, to be controlled with the negative. Yeah. So yeah, we underestimate if there's a degree, there's a negative impact or the treatment group, they'll be underestimated. Will be underestimated because of this. And when it's staggered, right? That's cause a problem. Right? Are we okay? Right? This the implication here. So that's an example of the you can see the nice way. This is something you can mimic if I do a study. The way to plot the outcome. And you can see with a graph, right? One graph is better than 1,000 words, right? And you can see from this graph, you can see, oh, the common trend is something to satisfy, but you can see also a huge impact, right? And how the impact grows over time. Right? Next paper we're going to discuss. Its example is by I think it's a famous paper, right? Very, very well known, especially studying corporate finance. I'm like corporate finance. I know this paper, so this got to be a very important paper. Bertrand and Molinetta in 2003. I think it's a JPE. Yeah. The title is "Enjoy the Quiet Life," right? Corporate governance and managerial preferences. So the idea is they want to study the effect of the anti-takeover law, right? I mean, the most important one, most prominent one is something called business combination, right? So business combination law imposes a moratorium 3 to 5 years on a specific transaction between the target and raider, and when this raider holding a certain past a certain threshold of the stock, right? Unless the board approve it, right? So basically, some certain transactions are not allowed, right? If the board does not agree, right? If the rate want to take this action, but the board does not, this law allow the board to say no, right? And of course, this will be a very powerful anti-takeover law, right? So this paper say investigate when the manager are not faced with the takeover threat because the business combination law passed, or are not closely monitored for the same reason, would they pursue goals that are not in shareholder interest, such that overpay, right? The employee, especially the employees, are unionized, right? And if you want to maximize shareholder value, right, you probably want to pay the optimal range, right? But if they want to avoid trouble, have a quiet life, as the title suggests, right? They don't want to argue with the union or antagonize the union, right? They might just say, okay, I raise everybody's wage, right? They are not very careful, right? And then by those kind of decisions might hurt firm value. So they want to study if passing the law has that effect, right? Has that effect, right? So they look at the wage of the white collar workers, okay? And this is the law, right? I mean, just a page out of the paper, right? This is another company, another state passed a law like that in a different time. So you can see this is, but they're all kind of staggered, but they are not too far apart, right? They are all within 86 to 1990, but most recent was 1991, but most of them happened at the same time, 1986, 87. When this law become very popular, everybody kind of mimicking. I mean, one will pass it, the other one. I mean, they were under pressure, right? The legislature in that state, we under pressure to pass it too. And that's why you see a cluster on the passing. So what they did is, in this paper, they have data that are different from the other, right? They have a data on the corporation, but they also have detailed data on the plant, right? So one corporation have a plant at different states possible, right? So they have the data at the plant level. They know which plant they pay what kind of wage the worker every worker on that particular plant. So the key thing here is this plant might locate in a state which passes the law, but also the same company, right? There are two plants. One is in Pennsylvania. Pennsylvania has a BC law, but they also have another plant in a state which does not have BC law. Right? So they're going to utilize. I think they argue they're going to utilize this one, and this a difference, and they're kind of arguing this is going to give them a more powerful test because they allow them to control for the firm fixed effect J or the L. See, so you can see they have an index here. J is a state. Right? You might use this. J is a state. T is a time. L is the location of the plant. L is the location. This particular plant in which state? Right. So that's so L index state or location, T index time, and J indicate with the J. Right. J is indicate the firm, basically. So So RT, alpha T is a yield fixed effect, J is a firm fixed effect. So J is a firm, K is a, you can, K is the state K, positive law, the incorporated state, right? And L is the location, and T. So they have four subscript. The author are concerned that the shock to a local economy, basically at the plant level, might coincide with the VC law passing. So they try to control for that, right? And the one way they argue they're going to control this by using this variable. The location, yield fixed effect, right? RL times R alpha T, right? L is the plant level, T is a fixed effect. So it's like a plant fixed effect. The plant yield fixed effect, the interaction. Okay? And they have an individual, right? The I is a plant. Okay, I'm sorry. I is a plant fixed effect, right? K is a state or incorporation fixed effect, right? Which state are incorporated, and that's where the law passing, right? State incorporated the law. And so what the control is alpha T, that's time fixed effect. This is a plant fixed effect. This is a state or incorporation fixed effect. Okay, and this is the point. This is the location, right? State and E fixed effect. The L is the state of location, right? So they worry about the low passing is because the plant located the economy, right? They might affect the low passing decision. So they want to control. They want to run this equation here. RF times RT. They want to use out control. Then, at the time of 2003, it's an Apple already, not Apple in the year coming out, right? They said we cannot run this regression. It's we don't have lack of computer power, right? At the time. Now it's no problem, right? But at the time, 2003, right? They cannot run this regression. Even they want to do it. So they find an alternative. They're using the instead of this one, RL times alpha T, they use it as a lag value, right? And for that say minus I, meaning exclude the form they're talking about, I here. And they run this situation, they're arguing the delta here will measure the difference in difference. Basically the low passing effect on the wages. Okay, is that clear? The setup, right? So there's the tool, there are the level, there the data of the wage at the level of plant level, and the plant is in state indexed by L, right? And but the company itself can be incorporated in state K, right? The state incorporation, right? So you can see they have an arrow, they have K, and they have the I or the firm, and they have the J. So with the J, yeah, there's a. I forgot what's a J. Yeah, they don't have a J. I need to look at it to look back to see what's in J here. But that's not the point I want to emphasize. Oh, this is a firm. J is the firm fixed effect. So JKLT. Well, I think that I'm gonna copy the. I did not excluding the. should be one. I should be one. Okay. But this is the result. Basically, they want to see the wages affect the VC. and you can see that under the different, right, with the BC law itself, right, the wages increase, right, by 0.013, and I think this is the standard deviation of the estimate. So clearly, this is significant increase. So basically, when BC law passed, the firm in the law passing state, they raise wages in that form. Okay? And that the user to argue the manager enjoy quite a lot. They want to fight with the, they don't want to fight with the employee, and they just want to make everyone happy. Right? And they may make their job more secure. Right? And you can also see, right, this is without control, but they're worried about they're putting the state year fixed effect, but they're using the Y to proxy for that, right? So this is not really a state year fixed effect, but you can see that that's a major impact too. I mean, all those wages apparently are affected by the state economy. That's basically what it says. And you can see they also have this. Before they were 0, -1, the 1 year before, and they 1 year after, 2 years after. So this is the same as the previous paper, right? You get T-1, T-2, right? All the way up to T-10. But here they only look at T-1. They're afraid to look at T-2. If you look at T-2, it might show us something different. But we never know, right? Because they never report it, right? But what I want to see, you want to show is this thing, right? You want to test the parallel trend assumption are satisfied or not. They look at this value, right? T-1, right? 1 year before, and this is insignificant, right? But it made me, it's kind of suspicious, right? Why you look at 2 years after, but you only look at 1 year before, right? Especially the common trend, right? Probably want to look at a bit longer, right? But I guess if they do a longer one, they might find some surprise there, right? But the thing they want to draw is this is significant, and this is significant, and this is significant, right? There's an immediate impact on year 0 and year after, and the second year after, even larger second year after. Okay, so that's they use it to argue the BC law effect is an impact. Okay. But now I want to argue, right, what they did not do is they did not deal with the issue that a state, say Nevada, passed certain law, right? Could that be due to the economy, right? I mean, remember the dependent variable is wages, right? Could be some statewide economy factor affect contamination of law passing. They are not related to the law, but they just happen at the same time, and they affect the wages, right? Because when the economy is doing well, everybody paying wages. And at the same time, this is the time when the law passed, right? And it's possible, actually, it could be when state economy is doing well, right? And the union, right? They probably have a better position to lobby for the law passing, right? And so that this law passing, the BC state law could be indulgent. You can tell a different story, right? But you want to rule that out. And it's very likely, right? Because of the wage, another thing can affect wages, right? And the state economy certainly will do that. And whatever if state economy, right, they actually come back to affect the law passing, right? And they also affect the wages, right, at the same time. So what you show the BC impact is not because the BC, it's because state economy, they affecting wages, right? So that's something they did not take care, right? They did not take care. And that's why I argue, okay, I mean, we can do a DDD, right? Instead of difference and difference, you could have a DDD, difference and difference and difference. We got to see how that is possible after later on. Right? Next paper is similar. This paper actually they just copy. They just copy this paper, but they just apply different law. Right? This paper in the marine science. Okay. They just change the BC law to constituency stations. And constituency station said there are in 34 states between 1984 and 2006 passed these statutes that allow corporate director to consider stakeholder interests when making a business decision. Before, the board director or CEO should consider only the firm value, right? The maximum shareholder value. But now they said this law said it passed. They allow the manager to consider other things, non-shareholder, maybe the police or the same state or whatever, or other considerations. The stakeholder which is might directly affect welfare. So they want to study what if this state passing this law, would the state have a better innovation, right? See, there's a literature innovation come up at that time, right? And they have this constituency statute. They find out they have this law passing, they search, and they find out that this law change, and they just want to see does this law change affect the innovation, basically. And of course they need to try very hard to come out with the possible explanation, the channel they think innovation. So they have to look for evidence or look at story, and they said, well, and you talk to evidence abound with the example of an innovative company engaged in vigorous interaction with a non-financial stakeholder, include employee, customer, and community group. So their stakeholder, basically, it's an example of group. Employee, not necessarily the shareholder, right? So before, the manager should only consider the shareholder interest. But now this law passed, now manager can also consider, it will not be sued, right, by the shareholder if he also consider the employee, the interest, or the customer, or the community group. Okay. So basically this law provides a shield, right? And against whatever if the CEO or the firm manager just cancels on one person, I take something which is not only maximize shareholder interest, but also consider interest. And in the early time, this might be sued by shareholder, right? The shareholder might say, you're wasting money, but you're not maximizing my firm value. And with this law passing this statute, this statute passed, right? And they will be protected by that, right? But this paper would argue, they said they have evidence or story to argue, right? This kind of company, if they consider the non-financial holder interest, these firms are more innovative. Okay? And that's why they set out to study, right? So, of course, this is a claim, right? It's often claimed to drive a firm ability to innovate. Basically, they argue if you treat employee nicely, right, providing them lunch, for example, like a Google, right, providing lunch, and without the firm, there's a better innovation. So this is the state pass, the statute law, right? And in '84, the state kind of the countries on 38 and in 1980, and some will spill over to 90 and 2000. So that's the regression in one. Right? Again, this is the panel regression, and just apply the simple DD, but they copy the previous specification. They also claim they want to run this regression with the time level and the location, the time, and also the form. But according to my reading, the innovation, I don't think they have innovation at the time level. They have innovation only at the point level. Right? But we got to say, okay, we got this data. We have more the can define the firm whether they are by the firm in the state in located, whether this is doesn't make sense for me. They don't have difference. You don't have the data, and like the reading table, then the data for the front level. Here, the innovation they only have the front level because we very hard to see whether they got the data, the innovation. It doesn't. But it turned out to be this thing can allow us later on when the propose we can do a PDD to test this, and that would actually this is the difference between the plant and the state, right? The location, basically location and the state or location of the plant or the firm and the state of incorporation. These two actually allow us to do a DDD better. Okay, to address the same problem, right? This statue passing might not be endogenous. Just like the previous paper, right? The paper, the prior life, right? BC passing might not be an endogenous decision, right? Same as here, contingency statute might not be exogenous at all. And what if that's the case? How are we going to deal with that, right? And it's one simple example again. So this is affected by the state economy, right? State economy at the time, because state economy is going to affect the innovation as well, right? The state economy provide attract better employee, and they're clever. They probably generate more pattern, right? Because that's the pattern is the measure of their innovation. See pattern and citation, right? So they just run the same regression, but now this time by this paper is this paper is this paper 2016, 13 years later. Oh, the earlier one. Now 2016 has enough power to run. This is the state fixed effect, right? You can run this one here. They can include this is location and the time, the fixed effect. Right? Because remember this is itself is a dummy, right? L it could be a 50 state, right? T depends on how many years, right? On the 20, 30 some year, 50 times 30 years, you get 1500 dummy, right? Just this one, right? So when you run the regression with a lot of dummy, that take a lot of power, right? But not a problem with today's computer. Maybe just take me longer, but it's feasible, right? So they do it, and they show the regression result. See, they also do it 1, 2, 3, 4 years before, and 4 years after, and they want to say, okay, nothing before, and all the effect after, and it's positive, right? It affects positively on the innovation. So it's consistent with their hypothesis of what they want to show. The statue, continuous state passing, statue passing, told the innovation. Bear in mind, this state, this low passing is may not be exogenous. And how do we take care of that? How do we take care of that? You want to address, how do you address that? So this is why I learned from this paper. This is a very nice paper, very clear. Okay. Idea of really showing how the TDE is about. I kind of urge you to read this paper. So this is the AER 1994 by Jonathan Gruber. Okay. They're going to show what happened if a firm increase a benefit, group benefit, medical benefit. Right? They provide the benefit to maternity leave, for example, or pay for their expense. Right? So these only have to do certain group, right? Only have to do women most of the time, right? And also have to do women below 40, right? So it's only a group specific mandate. And they want to study one objective, they want to study how would this benefit, the cost of this benefit, is that really costly to provide benefit to this firm? If a state mandate a corporation need to pass this law, need to provide this kind of benefit, would that really cost the firm? Because alternatively, they said this cost will reflect in the wages, right? They provide you more benefit, but they reduce the wage, right? And in a sense, it's not really costly to a firm, right? Because they pay low wage, even if they provide benefit, but they only provide low wage to those people who receive benefit. So again, this is a very clever study, right? To study whether this wage reflect the benefit, whether there's a kind of a substitution, right? If a company provides more benefit, can they reduce the wage? That's the case. We found that we have that, right? And how do they do that? How do they do this, right? Because this is also low passing, right? Low pass again affect. I mean, the low passing of law is most of the time could be endogenous, right? Endogenous cheating, right? And so this is what I just said, right? The paper study if the cost of benefit reflect in the wages of employee, i.e., low wages, after state pass a group mandate requiring firm to extend multi benefit to their employee. Before there is no law, and the firm can elect not to provide benefit. Some firms will provide, but some firms will not. So this paper has that's the problem. They're going to choose a comparison state. They are able to choose a comparison state, a control state instead of a stagger, right? Remember the caution I had about the stagger, then the previous state, treaty state become control. But there's no problem here. If they can clearly define the state which is treated, which is controlled. And also this law actually, this thing they study kind of clustered in a few years, only within the 3, 4, 5 years apart, right? And so they, in some sense, they kind of combine them together. I mean, you can see that when you run regression. But basically, this is what happened. Okay, I use the table first to show you. Then we go to see the regression. So they have two things. One is called experiment state. You can think this is a state pass the law to require the firm to extend the benefit. And so this is the control state here. We talked about here earlier. We point out, right? 3 states. This is experiment state: Illinois, New Jersey, and New York. Okay, and the other are the non-experimental state. Yes. Now, beside this, there's another dimension. So this is a dimension of the state and time, right? Now, the reason that we got to consider DDD because now we have another dimension. Just like earlier example, we had time, level, and state, right? That would help us to design DDD because DDD requires three dimensions, right? So we have individual, right, which is treated, meaning it's not affected by the law, or it's going to receive the benefit, right? And which might getting a low wage if there's a substitution happening, right? Or there's a control group, it's non-treated one, right? Can you see the difference? There's a state difference. Some state pass a law, some state don't, right? The state pass a law called experimental state. The one doesn't pass a law is non-experimental state. Now, within the same state, or even the same firm, right? We have an individual which receive benefit that treated by would affected affected by this law, right? Because they don't receive the benefit, right? And you can have a group which is all the same state passing the law but not receiving the benefit, right? And what if you think of maternity, right? What do you think? Well, that's the treated one. Got to be individual, married woman, and between 20 and 40. 50, you don't receive. You're not going to have a child, right? You're going to receive any benefit. And also, if you're a man, usually, right, at that time, you're male between 20 and 40. Usually that's a non-traded control group, right? So can you see that? Three dimensions. State describe experiment passing a law and not passing a law, right? And the individual, treated, not treated. Treated meaning affected by the fund and affected by this law and that, right? So a regular DDD would look like this. You would just look at this group, right? The top panel, right? This would be DD. We can just do this, right? And this DD show there's no what the I think this is a significant difference. You can see the wages reduced, right? You can see this DD, right? Difference just from the top panel. And regular DD, just two dimensions, right? Just a state and time. And for this DD, we see there's a reduction in the wages. For this person with a low pass, the firm, right, or this individual actually receive the benefit actually have a low wage. But now, as I said, this thing, low change might be affected by the state of economy, right? The state which pass the law are likely the state are doing well, or are foreseeable to do well in the economy, and that's why they can afford to force the firm the benefit, right? So there's a strong suspicion, right, or concern that this law change, right, might be endogenous, might be affected by the economy at the same time, the shock to the economy at the same time, right? So the second DD, try to together. Second DD. Second DD is the group affected by state of economy, just like this one, just like the top one, right? The same thing, same bias, which we think would affect the top panel, should appear in the second panel as well, right? But the only difference between the top panel and second panel is the second panel individual does not have an effect, does not affected by the law change. They affect the economy, but they are not affected by law change. And so we want to using these two DD kind of wash out. This is the state shock to the economy effect, right? And that's what they did in the second degree. Right? If there's a impact on state economy affect the low pass, they're going to see it here, right? And that bias is also in here. So you take a difference, that's going to eliminate that bias. So it's very clever. I think this is very clever, right? And you can see that much actually. The concern might be overblown, right? Because we don't see the significance, but it's negative, and it says some looks like there's some impact, but it's not significant. Okay, so EDD, right, is very significant, right? So you can this give you an idea when you want to design the EDD. When you suspect the treatment decision might be endogenous, right? You want to consider a similar situation, right? Right? You want to find a group which is only affected by the thing you're worried about, but is not subject to the main effect, the treatment change. And use that is another do that is another meeting and take a difference of that. Okay. And when you do this equivalent to run an equation like this. You have 3 dimensions, right? And tau t, since I think in this case, the tau t in a stagger situation, tau is a time the timing either after low and it's before, right? It's same as a post. But here, if the low pass is staggered and they pass a different year, this tau t is supposed to be different by different state, right? By different state. But maybe this paper kind of foresee the criticism of this stagger thing, right? So they just treat it as a group. So if the low pass in the first year, then the second year is already treated. So they run this. And so you can see this is the regression equivalent to this table. It's the same as this table, but in fact they say all these variables are obtained. You can calculate this one as a group, right? Each group you don't know how to calculate wages, right? But they said actually they run this equation, and they also control for this one. Regression allow you to control this one, which is something you cannot do here. Just calculate the kind of portfolio return here or wages here. But they do it here. They actually all this value is just calculate within each group. They're using this one to back it out, using a coefficient to back it out, because each cell would corresponding to certain combination of this, the coefficient beta 1, beta 2. I mean, you can figure out how you want. If not, example, if I want a beta 7, right? That means treat I going to be equal to 1 and this equal to 1, and the rest is equal to 0, right? These 2 dimensions equal to 1, and with what? With tau t equal 0, meaning before. That will be the before, right? And that will be what? That will be this is equal to 1, this is equal to 1, so that will be corresponding to 1 and before, right? So we equal to, for example, to 1 of this set, right? But they have the benefit of being able to control for x, right? Some other characteristics. Okay. And also, I mean, also I don't want to repeat it, but you can see what is each individual conviction for the total capture, right? So I said that's why this I learned a lot from this paper. Now, see, I can apply what I learned from this paper to the previous two papers, which they didn't consider this endogenous possibility, right? Possibility, right? So I'm going to skip this, right? Yeah.
I'm not sure if PDD is you need to have the pass the law have different treatment individuals in that different states. You need to have the
No, they don't the state are the state are the state.
yes,
Right.
but within the same state you need to have treated it.
Right.
So is that relevant to pizza? There is the assumption there are two things.
Your company, you employee on the same state the law. I am employing with a woman until 2040. I have a male. And compare the male and the wages and the treated one is the female and the male which is not treated.
Yes, I know that. So PDD is a case where you have this kind of treated and untreated when passing the law. So if I don't have this kind of case, if I say that passing the law, all of them are treated. So so I don't need to.
Even you are the non-treated, but non-treated is even the treated. You are the 40. You're the female, but in a state without passing the law. So remember when you have this situation, right? You have three dimensions. You need to take care of the interaction. Some people just, my only, like this is a DDT, we want final DDT, beta A. But you need to have all the two, there are three dimensions. Each of two have to be interactive to be completely correct. Say this is the DDT, right? If you miss one of them, then you might do some bias. Might not capture exactly DDT. Okay, so this is what if I apply the PDD to the Bertrand and Monethan. And since they don't do it, so I don't remember it doesn't make it XX. But I know how to design it. And this is the DDD. So same thing, right? I have a state. This experiment state. You look at early table. This is a non-experiment state, right? The state which is passing a DC and the state that is not passing a DC. Right? I have a before and after, right? And I have a treated form, right? I have treated. Remember at the plant level, the treated one got to be this plant in the located in the state which is past the law. Right? So this is a firm located in the same state of incorporation. This will be treated, right? If this firm in a law which passing state, then it's affected because the plant is in that state passing the law. Then my non-treated one is they are different, right? State California passed the law but I'm a California firm, but my plant is located in Arizona, right? And that'll be this. And that'll be this, right? So if this VC law decision passing is affected by California economy, it will happen here. It also happen here, right? right? Because it's affected by the law, the passing, right? It's California, experiment state, right? Whether my plant, it doesn't matter where the plant is located. The same economy will affect that. But if my plant is outside of California, then I'm in this group. I would not be subjected to this BC law, right? The impact, right?
But now you are adding a state dummy variables, right?
Which one?
Delta J,
Delta J, right?
right? You are
Which one? This one?
Delta J and
Delta J.
this one, the 55 slide.
55, okay.
Slide.
Here, okay.
Okay, so now you have the Delta J variable.
There, right, Delta J, right? So
That's for state dummy variable.
that's for state incorporation.
Yes. So
Right.
maybe there are some omitted variable related to this.
Well, and that will be happening both, right? Because that's state of incorporation, right? This is the state which is passing a law. So if the state,
Don't you have to consider other possible potential?
that's what you mean. Delta J, right? Consider the fixed. That's the state fixed effect.
Yes, but maybe you should add some other potential explanatory predictor variable to the set of X.
Yeah, you actually include anything, but anything related to the state, we subsume, we capture by the state fixed effect, right? The unobservable one, but they are the same. They are all the same state. Whatever related state, will be happening. The kind of
I mean,
subsume.
maybe there are some other variable, explanatory variables that are related to the states.
Then no, we capture by state fixed effect, right? That's the purpose of the state fixed effect. It kind of capture all the unobservable, right? Which is not in the X, right? We talk about it later. So this is right. So whatever the thing I worry about happen here, but also happen here, right? And the net of it would be the intended the thing the impact which is intended. Same thing with this model, but I just everything is there except you can do the same thing, right? Constituent state, non-constituent state, right? Maybe around 20 minutes. I'm going to 10 minutes. Okay, I'm going to do a self promotion for paper I'm using. I'm the working paper now. How do I? Okay, thank you. Okay. So I made this paper with Professor Chen and Kevin Liao and Scott Lee, the working paper. We are going to this is the title, a reciprocal relationship between analyst and manager. So basically, we study a connected manager, a connected analyst. And the connected analyst, if they do something called total splitting, they're going to receive, they're going to take, they're going to using total activity to reach the manager. And in return, they're going to receive information. So in this case, connected analysts, connected meaning in the case here, meaning they went to the same school, a school connection. So we show a connected analyst doing this type of total splitting activity, they're going to have and they are more informed. Basically, that their analysts, their forecasts are more accurate. Their documentation is more portable, and because they have more information. Where the information from the manager. Kind of a preview. They got preview information to the manager. They got private access. The manager giving the private information. But we study what happened after the USFP when this is no longer the case. How would we found after the USFP this type of analysts, the Canadian analysts, still were more informed, meaning there's more information than the other, the non-Canadian analysts. And we ask why, how is it achieved, right? Now I no longer got the information from the manager, but directly the private disclosure. How am I still more informed? I'm a Canadian, I'm still more informed than the non-Canadian. Actually, we found this type of manager, right? After the GSFT, this Canadian analyst only more informed when the firm issue management guidance. So kind of opposite. What do you think, right? In fact, it's most likely the Canadian analysts are more informed. They have more information advantage. Before regular FD, if the firm doesn't issue guidance, we found just complete opposite after regulation FD. We found Canadian analysts informed only in the firm issue guidance. So in a sense, the guidance is the public information. Right? So public information actually help inform investor more informed. So that increased the information assumption. So that's kind of counterintuitive and surprising. But we found this paper actually said this is not surprising at all. A paper but called, but we didn't study here, yeah. Chanel and Levine, 2010 accounting review. They show that public information can help turn non-material information, private information, but non-material, for example, industry information. I can still get information from manager about industry trend, as long as it's not related to the particular firm, my firm. So I can still do that. I can still go to do the private visit to the firm, right? And I can sense, right, the top manager, as long as it doesn't give me the direct information about the company, that's legal. Right? So in the sense that manager still got the information. I mean, analyst still got information through private if they're Canadian. But this information by itself might not be important, might not be material. Only when they also announce the public information about the firm. For example, one example we cited in the paper is I have information about industry trend. Say industry demand will go up. The firm announced there's an inventory build-up. Inventory build-up can be caused by two things. One is I cannot sell my stuff. Right? Inventory is piling up. The other one is I need to produce a lot to meet the demand, future demand. So to outsider doesn't have this industry demand information. Inventory number is non-directional in the sense that I don't know which way to go. It's a good news or bad news, I don't know. But I have some private information which is not complete, right? It's not material on its own, but with the help or the inventory build or the company, then I know this company is in good shape. Right? Because that tells me the direction, the reason of this inventory build. And this is something called information mosaic. They can complete information mosaic. Okay? So one thing we want to show is, okay, to do a better study, we ought to test, right? If the connected analysts become more informed when the company began to, after they issue the management guidance, because some firms never issue management guidance, So we look at a firm which started to issue management guidance. We want to see whether after the guidance, the connected analysts become actually more informed. Right? And that's consistent with the information mosaic. Right? And the implication of information mosaic is informed investors become more informed if there's a more public disclosure. That's a very, very counterintuitive. Right? But as I said, this is predicted by information mosaic. So that's the test we're going to run. Right? We're gonna see study the firm, issue guidance for the first time, compare before and after. Compare the benefit, the information, advantage of the connected analysis. Okay? And again, we are worried about this. Many parents' decision might not be completely exaggerate, right? So we are worried about something which might capture the reason for the statewide or the firm-wide information might affect the guidance decision. So that's why we do. I mean, follow the same logic. We do a DDT, right? DDT is this is kind of similar to the state, experiment state, which is passing the law. Now here is the firm provide guidance, and this is the firm. This kind of analog to the previous level, right? This is the non-experiment state. This is the non-guidance firm, right? That does not provide guidance. We look at the before and after, and we look at two groups. Remember, treated individual and non-treated individual. Here we have a connected analyst and non-connected analyst. Right? Remember, connected analyst is the one which is going to receive affected by the guidance, right? Because the connected analyst is the one who's going to have industry information, demand information. This group doesn't. Right? So again, the same setup, let's give you an idea, right? In the Google paper, I compare that to the situation here. And we found, right, DD, one DD, another DD, then it's a DDT, right? Very significant. Right? After the firm issue guidance, previously informed one, the connected analysts become more involved. So public information actually increase information intelligence. Right? And as a reverse, we also look at secession, right? Some firm previously issued guidance but stop doing it for whatever reason, right? And we do the secession decision as well. And what happened? Just complete opposite direction. Right? So we are pretty confident, right? This is something really kind of support this information mosaic story we need to